Hello students, today we are going to discuss some of the important questions of chapter Polynomial class 10th. So let's start with question number 1, and the question is, if x plus a is a factor of 2x square plus 2ax plus 5x plus 10, find the value of a. Since x plus a is a factor of the given polynomial, it means that if we put x plus a is equal to 0 and we get the value of x is equal to minus a. So when we put x is equal to minus a in the given polynomial, the polynomial becomes 0, right? So by replacing x by minus a, we write this polynomial is equal to 0. Look at this, 2 into x square. So instead of writing x square, we write minus a whole square plus 2 into a into x. Again minus a instead of x, and next 5x. So this is 5 into minus a plus 10 is equal to 0. Okay. When we solve it, we get 2a square minus 2a square minus 5a plus 10 is equal to 0. 2a square gets cancelled with minus 2a square, and minus 5a plus 10 is equal to 0, and when you solve it we get a is equal to 2. So the value of a is 2. The question was x plus a is a factor of the given polynomial. So zeros of x plus a is x plus a is equal to 0. The value of x comes minus a. It means if we replace x by minus a in this polynomial, that polynomial becomes 0, correct? And we get the value of a as 2. Now come to the next question, that is question number 2 here. For what value of k minus 4 is a 0 of polynomial? Minus 4 is a 0 of px. Minus 4 is the 0 of the given polynomial. Right? The polynomial is this, x square minus x minus bracket start 2k plus 2 bracket close. Since minus 4 is a 0, it means instead of writing x, we write minus 4, and px is equal to p minus 4 is equal to 0. Okay, since minus 4 is a 0 of the polynomial, it means if we replace x by minus 4, this polynomial becomes 0. Look at this. Put the value of x as minus 4, this polynomial becomes 0. Okay. Now solve it. Minus 4 whole square is 16, minus into minus 4 is plus 4, minus bracket start 2k plus 2. When we open the bracket, we get minus 2k minus 2 is equal to 0, and 16 plus 4 is 20, 20 minus 2, 20 minus 2 here, 20 minus 2 is 18, so we write 18 and minus 2k as it is, and minus 2k is equal to minus 18, so a k value is 9. The value of k is 9. Now come to question number 3. Find the value of k such that polynomial x square minus bracket start k plus 6 bracket close into x plus 2 2k minus 1 has sum of its zeros equal to half of their product. So important thing in this question is this. This is the condition given. Clear? The condition is, what is the condition? Find the value of k such that the polynomial x square minus k plus 6 bracket close into x plus 2 into 2k minus 1 has sum of its zeros equal to half of their product. Sum of zeros is equal to half of their product. This is the condition given. Clear? So the given polynomial is this, right? Now alpha and beta. If alpha and beta are two zeros, then what is the sum of 0? Sum of 0 is alpha plus beta, and we know sum of 0 is equal to minus b upon a. This is sum of 0 is minus b upon a. In this question, the value of b, that is the coefficient of x, The coefficient of x is minus bracket start k plus 6 bracket close. This is the coefficient of x. So minus b upon a. So minus into minus becomes plus here, and we get finally k plus 6. The value of alpha plus beta is k plus 6. Now the product of 0. Product of zeros, you know that, c upon a, right? So c is constant term. In this question the constant term is 2. This is the constant term, and 1 is coefficient of x square. This is 1, and here the coefficient of this x square is 1. So alpha beta comes 4k minus 2. So alpha beta comes 4k minus 2. Now it is given that this is the condition given, the sum of zeros is equal to half of the product. So sum of zeros, alpha plus beta was k plus 6. Product is 4k minus 2. So k plus 6 is equal to 1 upon 2 into 4k minus 2. Now by cross multiplication we get this 2 with k. When we multiply this 2 with k, we get 2k, and 6 with 2 we get 12 is equal to 4k minus 2, and the value of k comes 7. So the value of k is 7. The question is clear, right? The question is find the value of k such that the polynomial has sum of 0 equal to half of their product. So this is the condition, and initially alpha plus beta का value find किया, then alpha beta value, and then put the value in this given condition, and the value of k, that is the value of k, comes 7, right? Now come to question number 4. If alpha and beta are zeros of the quadratic polynomial 4x square plus 4x plus 1, then form a quadratic polynomial whose zeros are 2 alpha and 2 beta. Whose zeros are 2 alpha and 2 beta. Okay, in this question we have to make a polynomial, okay, whose zeros are 2 alpha and 2 beta, but the initial condition is, initial condition of this question is alpha and beta are two zeros of a quadratic polynomial. Quadratic polynomial 4x square plus 4x plus 1. Okay, this is the initial condition. Then he's saying form a quadratic polynomial whose zeros are 2 alpha and 2 beta, right? So we start with the polynomial given here is this 4x square plus 4x plus 1. This is the polynomial. Alpha and beta are the zeros. So what is the sum of 0? Alpha plus beta is equal to minus b upon a is minus 4 upon 4. The coefficient of x is b, so here is 4. Coefficient of x square is 4, here is 4. So minus 4 upon 4 is minus 1. And the product of zeros, we know the formula. Product of zeros is c upon a, constant term of upon coefficient of x square. So here the constant term is a, 1 is the constant term, so 1 upon 4. So two results मिल गए आपको. Alpha plus beta, here alpha plus beta is minus 1 and alpha beta is 1 upon 4. These results we are going to use further. Look at there. Now for a quadratic polynomial whose zeros are 2 alpha plus 2 beta, so we know that to form a quadratic polynomial, this is the formula: k x square minus sx plus p, where s is sum of zeros and p is product of zeros. Clear? Sum of zeros. So k x square minus sx plus p. Now we have to make a quadratic polynomial whose zeros are 2 alpha and 2 beta. So initially get s, that is sum of zeros, that is 2 alpha plus 2 beta. You can take 2 common. 2 into alpha plus beta. Now the value of alpha plus beta is here minus 1. So put alpha plus beta minus 1. So minus 1 when you multiply with 2 we get minus 2. Now product of 0, that is p. 2 alpha into 2 beta is 4 alpha beta. The value of alpha beta is here 1 by 4. Right? So put this value here. 4 into 1 by 4 is 1. So the value of s. So here the value of s is minus 2. Value of p is 1, right? So put these values here and we get k is equal to x square plus 2x plus 1, where k is any constant. Here we take the value of k as 1 and our polynomial is x square plus 2x plus 1, right? So come to the next question, the question number 5. If the zeros of x square minus px plus 6 are in the ratio 2:3, find p. Zeros are in the ratio 2:3, we need to find the value of p. Clear? So question is simple. Look at this. Here let px is x square minus px plus 6 and 2k and 3k are two zeros. Why 2k and 3k are two zeros? Because it is given that the zeros are in the ratio 2:3. So we write 2k and 3k are two zeros. Now same thing, sum of zeros, formula is minus b upon a. So 2k plus 3k is equal to minus p upon 1. Correct? So here it comes 5k is equal to p. Say this is equation number 1. Now come to product of zeros. Formula you know, product of zero, that is c upon a. And the product of zero means zeros हमारे पास we have 2k and 3k. So 2k into 3k is equal to c upon a. C, the value of c is 6, that is constant term here, right? So 6k square is equal to 6 and the value of k comes plus minus 1. The value of k is plus minus 1. Now when value of k is 1, the value of p is 5 and the value of k is minus 1, the value of p is minus 5. Correct? So there are two values of 5. Now come to question number 6. If 1 0 of the quadratic polynomial 4x square minus 8kx plus 8x minus 9 is negative of the other, then find the zeros of another given polynomial, right? If 1 0 of the quadratic polynomial is negative of the other, so in this question we have a polynomial this, okay, 4x square minus 8kx plus 8x minus 9. So here we rearrange the coefficient of x. Clear? We rearrange the coefficient of x, we take x common and the coefficient of x, that is b, is 8 minus 8k. Clear? So now px is equal to 4x square minus 8kx plus 8x minus 9, and finally this is your polynomial. Now he's saying let two zeros are alpha and minus alpha, otherwise we take alpha and beta. But in this question, one of the zero, he's saying one of the zero is negative of the other. Look at this, one of the zero is negative of the other. So one zero is alpha, the another zero should be minus alpha. This is important step. Clear? Now easy, sum of zeros, we know the formula of the sum of zeros. Sum of 0 is minus b upon a. Put the value, that is minus 8k upon 4 minus that start 8 minus 8k upon 4. Now alpha plus minus alpha is 0. Now cross multiply, we get minus 8 plus 8k is equal to 0. Now the value of k comes 1. The value of k is 1. Now he's saying find the zeros of this. We need to find the zeros of kx square plus 3kx plus 2. Clear? So here the value of k is 1 and this is the polynomial. Put the value of k as 1 here and finally we get x square plus 3x plus 2 after putting the value of k in this. Now we have 3x x square plus 3x plus 2 is equal to 0 is our polynomial. By splitting the middle term we get two of the zeros as x is equal to minus 2 and x is equal to minus 1. X is equal to minus 2 and x is equal to minus 1. Now come to question number 7. If alpha and beta are zeros of a polynomial x square plus 6x plus k, x square plus 6x plus x square minus 6x plus k, find the value of k such that alpha plus beta whole square minus 2 alpha beta is equal to 40. This is the condition given. So here let alpha and beta are two zeros of this. Clear? Same. Alpha plus beta is equal to minus 6 upon 1 is equal to 6. Right? So alpha beta value is 6. Alpha plus beta is 6 and alpha beta is c upon a, that is k. So two values, alpha plus beta is 6 and alpha beta is k. After using the formula, you know alpha plus beta is minus b upon a and alpha beta, the product of 0, is c upon a. Now put the values of alpha plus beta here, that is 6, alpha beta is k, and now solve. 36 minus 2k is equal to 40 and minus 2k is equal to 4, and finally the value of k comes minus 2. The value of k is minus 2. Now come to question number 8. If alpha and beta are zeros of polynomial 5x square plus 5x plus 1, then find the value of alpha square plus beta square. Clear? Alpha and beta are zeros of polynomial px. So alpha and beta are the zeros here. Now sum of zeros, alpha plus beta, formula is minus b upon a. Here the value of b is 5, coefficient of x. So this is 5, coefficient of x square is 5. So this is 5 is equal to 1, right? Rather minus 1. And alpha beta is the product of 0, that is c upon a is, c is constant term, a is 5, so 1 upon 5. So two results in front of us. What is that? Alpha plus beta is equal to minus 1 and alpha beta is equal to 1 upon 5. Now alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha beta. You know, a plus b whole square is equal to a square plus b square plus 2ab. Now to get the value of alpha square plus beta square, that is alpha plus beta whole square minus 2 alpha. This is the formula which we are going to use. As you know, a plus b whole square is equal to a square plus b square plus 2ab. So a square plus b square will shift that to ab to the left hand side. So ultimately alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. Now put the value of alpha plus beta is minus 1. So minus 1 whole square minus 2 into alpha beta, that is 2 into 1 upon 5, and finally the value of alpha square plus beta square is 3 by 5. The value of alpha square plus beta square is 3 by 5. Now come to the next question. The question is, if both the zeros of the quadratic polynomial px, this is the quadratic polynomial, are equal in magnitude but opposite in sign, then find the value of k. Same question. Here px is k plus 2 bracket close x square minus k minus 2 bracket close into x minus 5. Up since equal in magnitude, opposite in sign, it means that if one of the root is alpha, another is equal in magnitude. So another is alpha but opposite in sign. So it means the sign means here minus 1. So we have two zeros, alpha and minus alpha. Clear? Now simple sum of zeros is alpha plus minus alpha is minus b upon a. Here the value of b is, look at this. This is the coefficient of x minus bracket start k minus 2 into x. So put the value here. Alpha minus alpha is 0 is equal to k minus 2. This minus, when we multiply with this minus, gives plus. So this is k minus 2, and finally the value of k comes 2. The value of k is 2. Now come to question number 10. If alpha and beta are the zeros of the polynomial x square plus 6x plus 9, then form a polynomial whose zeros are minus alpha and minus beta. So alpha and beta are zeros of, this is the polynomial. So value of alpha plus beta minus b upon a, that is minus 6 upon a is minus 6. Product of zeros, right, that is c upon a, c is 9, a is coefficient of x square, so this is 1, so it comes 9. So alpha plus beta value minus 6 and alpha beta is 9. Now quadratic polynomial whose zeros are minus alpha and minus beta. We have to form a quadratic polynomial whose zeros are minus alpha and minus beta. So sum of zeros, that is s, minus alpha plus minus beta. So we take common as minus alpha, in bracket we have alpha plus beta. So alpha plus beta value is minus 6 from this. So we put the value of alpha plus beta here. It becomes minus 6 is plus 6. Now product, that is p, minus alpha into minus beta is alpha beta. The value of alpha beta is 9 from here. Clear? So the values of s is 6. The value of p comes 9. And what is important? This required polynomial should be in the form k bracket start x square minus sx plus p. K bracket start x square minus sx plus p, where s is sum of zeros. Here the sum of zeros is 6 and p is product of 0. Product of 0 is 9. After putting the value, this is there, and now we say k is equal to 1, and finally the required polynomial is x square minus 6x plus 9 after putting the value of s and p, sum of zeros and product of zeros. Now come to question number 11. Find a quadratic polynomial the sum of whose zeros is 7 and their product is 12. Hence find the zeros of the polynomial. Again, good question. Sum of zeros s given है, product of zeros given है, right? And we know the formula for a required polynomial is k bracket start x square minus sx plus p. Here s is 7, p is 12. So we put the value and we get x square minus 7x plus 12 as a polynomial when k ka value is 1. Now by splitting the middle term, find the zeros of x square minus 7x plus 12. So x square minus 4x minus 3x plus 12 is equal to 0 here. Clear? So you can take x common, x minus 4 minus 3 common, x minus 4 here. So x is equal to 4 and x is equal to 3. They are two zeros of the polynomial. Now come to question number 12. The question number 12 is very important question with respect to the CBSE. Every alternate year we get to see these type of question in the board examination. Find other zeros of the polynomial x square plus x cube minus 9x square minus 3x plus 18 if it is given that two of its zeros are under root 3 and minus under root 3. So we have, this is our polynomial, okay, and there are two zeros of this polynomial, that is under root 3 and minus under root 3. Clear? Now since under root 3 and minus under root 3 are two zeros, it means x minus under root 3 and x minus minus under root 3 is a factor. When alpha and beta are two zeros, then x minus alpha into x minus beta is a factor. This is the concept. When alpha and beta are two zeros of a given polynomial, then x minus alpha and x minus beta is a factor. Here under root 3 and minus under root 3 are two zeros, right? So x plus under root 3 into x minus under root 3 is equal to x square minus 3 is a factor. If x square minus 3 is a factor of given polynomial, it means the given polynomial is exactly divisible by x square minus 3. Now come to the division process here. So here division process in front of you. Okay, when this is x4 plus x cube minus 9x square minus 3x plus 18 and divide with x square minus 3, the first term is x4. To get x4 here, we need to multiply x square with x square. So when you multiply this x square with this x square, we get x4, right? When you multiply this x square with 3, we get minus 3x square. Clear? Now change the sign. This is cancel. Now we left with the highest power x cube. Okay, now minus 9x square plus 3x square, because we have changed the sign here, right? We have to subtract as far as division process goes, right? So minus 9x square plus 3x square is minus 6x square, and minus 3x plus 18 as it is. Now we need x cube here, so we multiply this x square with x. So when you multiply x square with x, we get x cube, right? Then x with minus 3 is minus 3x. Change the sign, it's cancel. So minus 3x plus 3x, this is also cancel. So we left with minus 6x square here and 18. Now to get minus 6x square from x square, we need to multiply this x square with minus 6. So ultimately we get minus 6x square plus 18 upon minus 6x square plus 18. Now change the sign, this is plus and here is minus, and this is all cancel, right? It's 0. So ultimately the quotient is, now we have a quotient as x square plus x minus 6. To get other zeros, we need to find the zeros of this polynomial x square plus x minus 6 by splitting the middle term. X can be, we can break this x in two parts such that one is 3x, another is minus 2x, right? 3x minus 2x is 1, so this is 1. Now take common. Now you have to take common out of these first two, x plus 3. Second में से minus 2 common, x plus 3, and finally we get two factors, x plus 3 and x minus 2, and the value of x is minus 3 and 2. So other two zeros are minus 3 and 2, right? Now come to the next question, that is question number 13. This is obtain all the zeros of the polynomial x square minus 3 under root 2x cube plus 3x square plus 3 under root 2x minus 4 if two of its zeros are under root 2 and 2 under root 2. Question is different but similar to the above question, right? So since, look at this now question. Under root 2 and 2 under root 2 are two zeros. It means of this, it means x minus under root 2 and x minus 2 under root 2 are factors. Clear? And it means x minus under root 2 and x minus 2 under root 2 is a factor of this. So when you multiply these two, we get this. So x square minus 3 under root 2x plus 4 is a factor of the given polynomial. Now if this is a factor, so we need to divide this. So divide the given polynomial with x square minus 3 under root 2x plus 4, right? So here x cube, here x4, x square, sorry, here is x square, and digits are not so much clear, but okay. X square with x square we get x4. When you multiply this x square with this, we get minus 3 under root 2x cube, and you multiply minus 1 with 4, we get minus 4, right? Now what's happening here, this x square with x square we get x4. Now x square with this we get minus 3 under 2x cube, and when you multiply this x square with 4 we get 4x square, right? Now change the signs and we get minus x square plus 3 under root 2x minus 4 here, and now we need to multiply this x cube, x square with minus 1. Okay, so when you multiply x square with minus 1 we get minus x square plus 3 under root 2x minus 4. Clear? So the quotient is, what is the quotient? The quotient is here x square minus 1. This is the quotient. Clear? Now to get other factors we have to factorize this. So when you factor x square minus 1 is equal to 0, you get x value as plus minus 1. So other two zeros are 1 and minus 1, and all the zeros under root 2, 2 under root 2, 1 and minus 1. Now come to question number 14. Find the value of a and b so that x4 plus x cube plus 8x square plus ax minus b is divisible by x square plus 1. We need to find the value of a and b. The condition which is given here is this polynomial is divisible by this, completely divisible by this. It means the remainder should be equal to 0. So now we follow the division process here. We divide this with x square plus 1, right? Now look at this division process. Okay, now to get x4, multiply this x square with x square. So we get x4, x square with 1, again x square. Change the sign. This is cancel. This x cube down. 8x square minus 7x square is 8x square minus x square is plus 7x square. Plus 8x square minus x square is 7x square. Now ax minus b is as it is. Now to get x cube we need to multiply this x square with x. Okay. Now when you multiply this x square with this x we get x cube. X with this 1 we get x. Now this 7x square here as it is, and plus ax minus b, and this is minus x. So out of these we take x common and a minus 1 into x. So when you solve this, when you take common as x, we get a minus 1 and minus b here as it is. Clear? Now to get 7x square, we need to multiply this x square with 7. So this is 7x square. 7 with 7 is 7, right? And this is cancel. And finally in the remainder we get this. But in the question px is exactly divisible by gx, so rx is 0. So this whole value is equal to 0. Woke up when individually a minus 1 into x is 0, right? It means x cannot be 0 here. So a minus 1 is equal to 0. If a minus 1 is equal to 0, the value of a is 1. And when the value of a is 1, so again this is the constant term, it should be 0. Minus b minus 7 is equal to 0. So minus b is equal to 7 and b is equal to minus 7. The question was very simple, is px is exactly divisible by gx. In that case the remainder is 0. Okay, this is the remainder. To make this remainder 0, if a minus 1 is equal to 0, then this term becomes 0. Okay, right? So we get value of a as 1, but now minus b and minus 7 is left. There should be also this minus b and minus 7 should be equal to 0. Only then remainder will be 0. Clear? So we write this minus b minus 7 is equal to 0. Now put here the value of b comes minus 7. So a is 1 and b is minus 7. Now come to question number next, that is question number 15. The question number 15 thoda sa gadbad. Yes, so the question is, what must be subtracted or added to px, and the px is given, so that 4x square is a factor of this. Now when we have this polynomial, this is the polynomial, okay, ओके ये थोड़ा सा स्क्रीन में गड़बड़ है. So this is the polynomial, and when divide this polynomial with this x4 8x4 plus 14x cube minus 2x square plus 8x minus 12, and divisor is 4x square plus 3x minus 2, right? So divide this 8x4 plus 14x cube minus 2x square plus 8x minus 12 with 4x square plus 3x minus 2. Okay, after dividing this, after following this process, whole process, we get remainder as 15x minus 14. The question was, what must be subtracted or added in the given polynomial? इस polynomial में we have to add something or subtract so that it is completely divisible by the given polynomial. But here the remainder is 15x minus 14. Clear? So what should be subtracted? Means instead of 15x minus 14, it should be equal to 0. It should be equal to 0. Then we can say that this px is completely divisible by gx. So 15x minus 14 must be subtracted from this polynomial. Clear? And what should be added? And now for what should be added, look at here. We have to subtract 15x minus 14. And what should be added? The negative of this. If we add the negative of this, means minus of this, then again we can say that our px is exactly divisible by gx here in this question. So whatever remainder is coming, we have to subtract that remainder from the given polynomial. If the question is what should be subtracted, and he is again asking what should be added. So the negative of, in this question, the negative of 15x minus 14 must be added. So what is that? Minus 15x plus 14 must be added, so that the given polynomial is exactly divisible by gx. Okay, now see the next question number is 16. For which value of a and b are the zeros of x cube plus 2x square plus a also the zeros of the polynomial x5 minus x raised to power 4 minus 4x cube plus 3x square plus 3x plus b? Now which zeros of this are not the zeros of this? So थोड़ा सा lengthy question है. For which value of a and b are the zeros of x cube plus 2x square plus a also the zeros of this? Okay, so to get this we need to divide. So we divide the given polynomial x raised to power 5 minus x raised to power 4 minus 4x cube plus 3x square plus 3x plus b with x cube plus 2x square plus a. Now the here very first term is x5, so we need to multiply this x cube with x square. So x5 plus 2x4 plus ax square, then change the sign. Clear? And now important thing is this. Look at this. थोड़ा सा zoom करते हैं इसको. Oh no. Okay. Look, this is cancelled. Here minus 2x4 and minus x4 is minus 3x4. This is as it is. Now look at this. Here x square, 3x square and minus ax square. When you take x square common here, when you solve these two terms, we get 3 minus a in the bracket. This is important step. Clear? This is important step. Means here this is converted into this one, right? And these two 3x and b we write as it is. Clear? ये important step है इस question का. And now further it is minus 3x square now. 3x4 minus 4x cube plus 3 minus a into x square plus 3x plus b. So to get 3x4 here, right? 3x4 here x cube we have to multiply with here 3x, right? So minus 3x you have to multiply. So minus 3x4 and minus 4x cube plus 3 minus a into x square plus 3x plus b is the first term here totally, and then you multiplying minus 3x with x cube, we get minus 3x4 minus 3x with 2x square, this is minus 6x cube, and when minus 3x you multiply with a, when you multiply with a here minus 3x, so it becomes minus 3ax. Now when you solve it, look at this. Now when you solve, this is cancelled. Minus 4x cube and plus 6x cube is 2x cube. Here 3 minus ax square as it is, no issue. But look at here this. You can take x common. This is the x, and we left with 3 plus 3a. Look, this is plus here, this plus sign. So this 3 plus 3a when you take x common and b as it is. Clear? Now the first term is 2x cube. Clear? Now we have to multiply this x cube with 2, we get 2x cube, right? Now 2 with minus 2x square we get, sorry, here we have plus. So when you multiply 2 with 2x square, we get 4x square, and when you multiply 2 with a we get 2a. Clear? Now solve this. Chaliye. No. Okay. Now 2x cube and this is cancelled. Now look at this. This is important step. Right? When you take x square common here, we left with 3 minus a minus 4. Out of these two, yeah. When you take x square common, we left with 3 minus a and minus 4 from here. So 3 minus 4 is minus 1 and minus a is here. So this is minus a. Okay. Now this 3 plus 3a into x as it is, this b minus 2a is as it is. Clear? Now important step. What is that? Rx is 0. Here the Rx should be equal to 0. So here we have 3 terms. Okay. To get Rx as 0, these 3 terms should be individually equal to 0. These 3 terms. Right? So we take the first one. Coefficient of x square is minus 1 minus a. It should be equal to 0. So we get the value of a is minus 1. Second term, 3 plus 3a bracket close into x, so it's equal to 0. We get a is equal to value as -1. And last, here b minus 2a is equal to 0, so put the value of a as -1 here, so we get the value of b as -2. So a is -1 and b is -2. Clear? Okay, now come to the second part, is saying which zeros of px are not the zeros of gx here. Now here the quotient is, look at this quotient, factorize this quotient by splitting the middle term, and we get x is equal to 1 and x is equal to 2, right? So these two zeros 1 and 2 are not the zeros of this. Clear? So the question is clear to you. Initially divide this, make this remainder 0. We have 3 terms, 1, 2 and 3. Individually 3 terms are equal to 0, 0, 0. And we get a as -1, b as -2. Then come to the quotient, divide that quotient, get the zeros of that quotient, x square minus 2x minus x plus 2, by splitting the middle term. So value of x is 1 and value of another value of x is 2. So 1 and 2 are two zeros which are not the zeros of qx, right? Now come to question number 17. On dividing the polynomial px 5x4 plus x cube minus 3x square plus 2x minus 26 by another polynomial gx x square plus 2, if the quotient is px square plus qx plus r and remainder is 0, find p, q and r. Look at this again. Dobara. On dividing the polynomial px 5x4 plus x cube minus 3x square plus 2x minus 26 by another polynomial gx x square plus 2, if the quotient is this, okay, if we divide this, we get this as a quotient and remainder is 0, find p, q and r. Clear? So in this question we use division algorithm, that px is equal to gx into qx plus rx. So this is px, this is gx, this is qx, this is rx. Now here multiply, we get this, take common. Okay, so here we have a coefficient of x4, coefficient of x cube, coefficient of x square, coefficient of x, and without x term, right? So here look at this. Now we compare this. We have 1, 2, 3, 4, 5 terms on the left hand side and 5 terms on the right hand side. So here x4, here x4, x cube second terms, x cube, x square, x, x without x, that is constant term, and here is constant term. So similar terms on the left hand side as well as on the right hand side. Now on comparing the coefficients, on comparing the coefficients of like terms on both sides, we get p is equal to 5. Look at this. We get q is equal to 1, q is equal to 1, right? And r plus 2p is equal to -3 here. Clear? Now put the value of r is equal to -3 minus 2p. So here the value of p, when you put the value of p from here, the value of p is 5. So the value of r comes -13. The value of r comes -13. Clear? So the question on dividing the polynomial 5px is equal to 5x4 plus x cube minus 3x square plus 2x minus 26 by another polynomial gx is x square plus 2 if the quotient is 5 px square plus qx plus r and remainder is 0. Find p, q and r. Right? So by using division algorithm we have to solve and then compare the coefficients of like terms on the both sides and get the result r as 13 minus 13. Right, now come to the question number 18 here. Find all the zeros of the polynomial 2x4 minus 9x cube plus 5x square plus 3x minus 1 if two of its zeros are 2 plus under root 3 and 2 minus under root 3. So look, here these are two zeros. If 2 plus under root 3 and 2 minus under root 3 are 2 0, then we can say that x minus this into x minus second 0 is a factor of this. When alpha and beta are two zeros, then x minus alpha and x minus beta is a factor of the given polynomial. Clear? So x minus, okay, wait, a very important step here. Okay, look, x minus this is a factor of this. Now we open this small bracket, it becomes x minus 2 and minus under root 3 as it is, right? It's an important step. X minus 2 from this also, and minus multiply with this minus become plus here, right? Okay, now x minus 2 bracket close minus under root 3 into x minus 2 plus under root 3 is a factor of this. Now look at this, this is in the form of a minus b and this is a plus b. How? X minus 2 here, x minus 2 here, under root minus under root 3, this is minus under root 3 and this is plus under root 3. So ultimately this is a minus b into a plus b is a square minus b square. When you solve this, we get x square minus 4x plus 1 is a factor of px. Clear? If x square minus 4x plus 1 is a factor of px, it means it is completely divisible. So do this division process. The division, after doing this division process, this is 0 and this is the quotient, and the quotient is 2x square minus x minus 1 after this division process. Now get the factors of 2x square minus x minus 1 here by splitting the middle term. Okay, so 2x square minus x minus 1 is equal to 0, splitting the middle term, 2x square minus 2x plus x minus 1 is equal to 0. Now you can take 2x common, x minus 1 plus 1 and so on, and finally the value of x, is x is equal to minus 1 by 2 and x is equal to 1. All zeros, 2 plus under root 3 and 2 minus under root 3, minus 1 by 2 and 1. Okay, now come to question number 19. Find the zeros of the quadratic polynomial 5x square minus 2 under root 5x minus 3 and verify the relationship between the zeros and the coefficient. Question is simple, important hai, but 4 zeros, look at this, 4 zeros, splitting the middle term, so zeros are these. So one of the zeros is x is equal to minus 1 by under root 5, another zero is x is equal to 3 by under root 5. So sum of zeros 2 under root 5 upon 5. So instead of writing this 2 under root 5 upon 5, we can write minus 2 under root 5 upon 5, which is in the form of minus coefficient of x upon coefficient of x square here. Similarly, product of zeros, minus 1 by under root 5 into 3 upon under root 5 is equal to minus 3 upon 5 here. Clear? Now constant term upon coefficient of x square, minus 3 is the constant term and coefficient of x square is 5. This is 5. Clear? So it's verified. Next is, if alpha and beta are the two zeros of the polynomial 25p square minus 15p plus 2, find a quadratic polynomial whose zeros are 1 by 2 alpha and 2 beta. Clear? So it's simple. Alpha and beta are the zeros of this. So we get the alpha plus beta as 3 by 5 by using the formula. Alpha beta is c by a, that is 2 by 25. So alpha plus beta is 3 by 5 and alpha beta is 2 upon 25. Now for required polynomial whose zeros are this. Okay, we have to make a polynomial whose zeros are 1 upon 2 alpha and 1 upon 2 beta. So sum of zeros we require this. 1 upon 2 alpha plus 1 upon 2 beta. Take the LCM. So we have alpha plus beta upon 2 alpha beta. So alpha plus beta, put the value and the value of alpha beta also, we get the required result as 15 by 4. And product of zeros also, that is 25 by 8. And this is the formula, you know that required polynomial is in the form k x square minus sx plus p. Put the value of s, put the value of p. Clear? And after putting the value of s and p, the polynomial becomes 8x square minus 30x plus 25 when you take LCM, where k is equal to 8. So today we discussed 20 important questions of polynomial, class 10th, chapter 2. Right? And practice these questions. Okay, each and every question you have to practice, and that's it. Thank you.